Hello, this is Paul from Foresight Tech. In this lecture, I will going to introduce integration by parts. It's very important. It's as important as substitution rule. Okay. And first, we're going to use this method to evaluate the indefinite integral. Okay, here is the summary. So, what is the integration by parts? Here's first the formula. The later we're going to prove for you. Okay, so we look at it, and this formula f. So we look at it. This is the integration, indefinite integration. If this part is very hard to calculate it directly, so we can use what, and the product of the sum of the product of the two functions minus another integration. We look at it. This integration similar with that, but we change the order and change the position of the derivative, right? This is the original, and usually we will not view the integration by parts. Use this. This is complicated, and we like this term. So can you see the common view? We like this. Okay, so we like this common view. We usually use this to do calculation much simpler than the original. Okay, so how to get this? In the original, we set up u equals f. So v equals g. Therefore, I will put here. So what is? So this is a u, right? And then v equals gx. So this is what? And the g derivative of g times dx should be du. And then we see this is du. No, sorry, dv. Okay. So can we see? The left is u and the dv, right, equals what? And we know this is the function u, this is the function v. That's the function u times the function v. Then minus, so this time what is here? G is v. We just change. The original is u, now goes to v, right? The original is derivative of g, now here is derivative of f. F is u. Okay, so you put this together, you will see this is what? This exactly is du. Okay, but here is what is du. And that's another form is like this. Then we said we use this form, we like this form much better than the original. Okay, however, they are exactly the same, right? They are exactly the same. I put this. And so here is a remark which is very important. Okay, so this is very important. So this remark to guide us how to set up a u and the v, right? If usually we have the original is this is the original integral. We need to set up a u and the v. Where is u? Not always u is f, okay? Not always dv is the bottom. Sometimes we need to change the order, okay? We can rearrange it. A times b equals b times a. So how to set up a u, how to set up a dv is kind of a trick. So we need to set up in this. So we look at the right here. Usually we need to set up a u as what? After we take a derivative or take a differentiation, du goes much simpler than the original u. Okay, so the du should be much simpler than the original u. So this we can do the calculation easier than the older one. The second, if we set up du, like if we set up du is a function, so we need to do what? We need to solve for dv. So we have to solve v because here we need a v, right? If we set up dv, we need to solve for v. Usually we say v is resolvable. So we follow these two. So the first, up here, the first when you set up a u, du should be much simpler than the original u. The second, if you set up a dv, you should solve for v. Okay, v is resolvable. So that's all. Now we look at how to prove. It's much simple. So you can imagine the left, if we plus the right term to the left, and they see f g derivative, g f derivative is just a derivative of a product. Okay, so we just can go from derivative of product. So which is what I put here. If I say f times g, this is product, and take a derivative. Everyone knows this is famous, right, in Calc 1. So I write this, I follow this way, so it's what? I use f times g plus g times f prime, g times f prime. See, that's all we need. And then we take a derivative, okay, no, sorry, we take a integration. We integrate the left, integrate the right, what do we get? So this take an integral, means the antiderivative of f times g is what? Fg take a derivative is the left goes to fg. Take an integral to the left. So we take an integral to the right. Take an integral to the right, we separate it into two integrals. So which is this fg. The variable, of course, I will follow that. We use dx. See, that's dx, right? And the plus integral of this term prime, and then that's dx. See, and it is from the first is just an integral both sides. Okay, it's just an integral both sides. And can you see it's almost right? What do we need? What do we need is this. See, from the first left is this one is what we need. So everyone, can you look at it? Fg can separate it into two parts. Usually this we call it the first part. And if I say this is part 1, so can you see this is part 2. So integration, why we call the integration by parts? That's the reason, because we have one part and the two parts. Okay, the first part, the second part. If the first part is difficult, if this is hard to do calculation, and this, if this is easier, if this is easy to do calculation, so how to find this term? Of course, we can solve this term, and then we can use the results of the second part to find the value of the first part, right? Because the two parts added together is fg. So we solve the first. See what do we have? It's just the first is fg prime dx. The hard part we can solve it by fg minus the easy part, which is g f prime dx. Okay, so that's the proof. Can we compare this to this formula? That's exactly the same. And this is the proof. And usually keep in mind I will going to show 3 examples how to use this form. Okay, the first is the same as the second. We were going to use this comma view. We need to set up u. Keep in mind we need to set up what is u, what is dv, and then we need to find what is du and what is v, right? Okay, that's all we need. Look at it one by one. 3 examples. So the first, so here I said can we see u and v? No, we don't have here. So usually the first step we need to do this. We need to set up by ourselves, set up what is u, what is dv, and then to find out what is du and v. Have a look at it. So how to set up normal way. Okay, remember how to set up a u. If I set up a u is x, so I simply say if this is u. If I set up this is u, then what left is what is dv, right? Okay. If I set up, do you think this is good? Is this setup good for us? So remember, so we have remark. So first, if I set up a du should be much simpler than u. Can we see? Original u is x. If we take a derivative, x goes to 1. Okay, so du is much simpler than dx, right? Sorry, so much du is the derivative of u is simpler than x. So that's good. The second, and we set up dv equals this. Can we solve for v? Means what? V is a function. Which function take a derivative goes to ex the power, which means v is the antiderivative of e raised to the x power. Definitely is e raised to the x power itself, right? That means we definitely follow the remark. So I will go into this. The first, we need to find what is du, and the du is dx. See, is 1 times dx. 1 is simpler than x, so that's good. If I say this is simpler than x, the second from here we know is resolvable, right? If I put it here, resolvable, because we can solve v from this equation. So when we solve v equals e raised to the x. Okay, so what do we find? So v equals e raised to the x power. So now it's good. Okay, then we find everything. We set up a u dv and then we solve for du and v, because both we have to use in the formula. Okay, and let me show you the formula first. This is the formula: u dv equals u v minus integration v du. Okay, do you remember this? Okay, we just find that this is a common view. Usually we will use this is the formula integration, right, by parts. Integration by parts. Okay, and then we say this, the first part difficult part, and the second part easy to do calculation. See, and then when we set up u, what is u? This is u. Then what is dv? dv is this term. That's exactly the question. And the u we have, and the v, do we have v? See, this is why we need to solve. The second minus, do have we solved v? Yes, we do. Do we know what is du? Yes, we do know. See, you plug that into this formula, we have everything. So now I just plug in. What is the left is the questions. Do you think it's the question? Yes, because u is x. dv is ex dx. If you like, you can put the dot there. Okay, and then what is u? U is x. This is v, e raised to the x power, e raised to the x power, minus, okay, I put it here, integration, what is v, e raised to the x power, v, right? What is du, dx. Okay, see, and the difficult one, we can use this simple one to calculation. Is this simpler than this? This part is easier than that part, right? This is integration by the easy part. Integration by the easy part, okay? And this is what we know. And that divided of Vx is the self basic formula we already have. So I get it. Minus e raised to the x power. Don't miss, okay? Don't miss, plus c. That's the first questions. Look at it. So now I hope you have some idea. Integration by parts, integration by the easy part, okay? But this is the most important. Everything here, which one the most important is set up. Set up what is u, what is dv. Okay, so I put here. Set up what is u, set up what is dv. Okay, should follow the rule. After we set up a u and the du, or u take a derivative should be easier than u. Okay, or du is simple. The second, when we set up a dv, v is resolvable. We need to find the v. Now, I hope this already makes sense for you. We use the same idea, go to the second and the third questions. Can we look at this question? So how to set up? Okay, still. Okay, we still going to set up. Okay, we say setting up. Do you think this is always the most important? Okay, can we set up u is x raised to the fourth power? If I set up this, it's good. Why? Because take a derivative goes to third power. It's easier. However, if I set up a u is there, so ln2x dx, this is dv. Can you find the v, which is the antiderivative for ln this function? Do we have a formula? We do not have a formula for antiderivative. Means what? This setup is not correct. Okay, is not good. It does not work for us because what? Because we cannot find the v, or we cannot solve for v. We have other ways. See what we can do. What I just show you a little. Okay, so we just say if we try this, and a lot of questions we just try first. Okay, if I try this is u, can you see? And then this should be dv, and then v equals what? We just say v is the derivative of this. We cannot resolve, right? Okay, it's not resolvable, it's not resolvable. You cannot find the solution for v function. Just say the second. Now we rearrange the order, means put this to the first, put this to the second. A times b equals b times a, and then we can set up u equals ln, this function. See, we just try. See if we can find, if I put it here, it is ln 2x, I guess the fourth power dx, they are the same, right? Definitely. And this usually we call the rearrange. Okay, we say rearrange, and we use this rearrange and when we do the substitution method, right? So now can we try? If I try, this is u, and now this should be what? Should be dv. Of course, this time what the derivative of the power? Its power itself. We can solve for v now. And do you think u take derivative because it's simple? Derivative of u is simple? Yes, derivative of ln is just the power function, right? The reciprocal function. That's good. That's all we need. Now I will going to what? We do need the derivative. Okay, because this is what derivative. This is a chain rule. Okay, so I will now put here to let you know what is du. That's what we need. Du is the ln 2x take a derivative times dx, right? Okay, we're going to, this is a chain rule, so the inner one is 2x, so ln t, take a derivative to t first, which is t, okay, 1 out of t, right? And then the inner function take a derivative, which is 2, and then times dx, right? And the 2 and the 2 we cancel, what do we get? 1 out of x and dx. So this is what we need. Okay, so I put here, so du we need is 1 out of x dx. Is this simple? Of course you say this is simple. And the derivative for u, 1 out of x reciprocal function, is much simpler than l, the logarithmic function. Everyone knows, right? Good. And then is this resolvable? Yes. After we resolve, v should be the derivative of this. Everyone know this v is what? 1 out of 5 x raised to the 5th power. Okay, so good. This is the first we need. So I simply say, if this is the first we need, the second we need. Now we have both. We have both done. Okay, good. We log into the formula. I show you the formula once again. Okay. One more time. U dv equals u v. I hope you memorize this, and then minus v du. Okay, so this is the formula we need, and then plug this in. What is the left? So u is ln 2x, dv is that, which means what? The left exactly is the original question, okay, or the question here is the same, okay, this is 1, 2 the same. Then equals what is u? ln, okay, I put it here, ln 2x, this is u. What's v? V is here, 1/5 x with the 5th power. Then minus integration, what is v? That I plug in x with the 5th power. Then du. What is du? Du is there. Okay, 6 times 1 out of x dx. See, that's your setting up. Everything is here. Now I just simplify. Okay, I cannot simplify. I just switch to order. Okay, this is the first. I think this we can simplify, right? X 5th, 1/5 we take out 1/5, and then x the 4th power dx. Now we have everything. Why? Because this is the derivative is power. Okay, and then I just plug into the value, the final So x raised to the fifth cell and 2x. Okay, you know how to work. This is a x raised to the fifth divided by 5, so it's 1 out of 25x raised to the fifth power. Don't miss the last plus c. See, everyone look at the final. It looks complicated. However, these two are okay, and this integration by parts help us to get what is the antiderivative of that. One more, the last. So it's still the same. Let me show you the first step, how to set up a u or dv. Okay, so we can try two ways. If you set up a u is this, take a derivative. You can think about it. If you set up a u is sine x, the derivative of sine x is cosine x. We don't think cosine x is simpler than sine x. Okay. However, if we set up a u is x squared, do you think derivative of x squared goes to the linear function x, 2x, right? 2x is a symbol. Linear function is a symbol than the power function, okay? Symbol than the square function. So we follow this. We follow this basically I set up. This is a u, okay? So what the left, this is a dv. We can say dv, what is the antiderivative? It's a cosine, negative cosine. So that's good. Now I will going to get what is du. This is easy. Du is 2x dx, right? From here, what is v? We know v is antiderivative that is negative cosine. That's good. See, the first setting up we already have, and then I have to write one more. Okay, so I still copy the formula. I put it here. The formula u dv equals u times v, right, minus v du, and then follow the formula. So the left is x squared sine x dx equals, okay, this is u, this is dv. So u is x squared. I put it here. V is times negative cosine x, okay, and then minus integration. But is v is that I plug negative cosine x is v. What is du? Du is 2x dx. So I put the 2x dx here. See, and this is already knows the function, and this I think is simpler than before. Why? Because the power goes down. And later I will going to show you this we call the reduction formula. Okay, why? Because the power or the exponent reduce, okay, from the power 2 to the power 1. This is easier than the first, of course. Wait a little, let me complete this step. Negative 1, okay, so I put a negative. I still put the x squared times the cosine. And then this negative goes to positive, so plus. Factor the 2 out, so that's 2. And here is a cosine x is better. I switch the order. Why? Because I will going to do another. So can we skip one step? Okay. These are you the x times cosine x dx. Okay. X times cosine equals cosine x times x. Okay. Why do I do this? Because I have to set up the integration by part the second time. Go from here. We don't know this. We need to do one more time. So I want to set up. This is a u and this is a dv again. Why we do this? Okay, you can look at it. The first time x squared set up, u take a derivative goes to x. The second time x take a derivative goes to 1, right? So it gets simpler. And this v we can solve for v, no problem. If I solve, I put here. What is du? That's what we need, right? Du this time is 1 times dx, which is dx, margin symbol, okay. And then what is v? V is the antiderivative for cosine is sine x. Okay, so we need this set up and then do one more time. Let me see. What do we get? I copy this here. and then plus 2. To keep in mind that here is 2 terms, right? So I have to put the parentheses, otherwise you have to distribute it. Okay, don't miss this. So I put the big parentheses. What is the integration by parts? The form is there. Okay, so this time integration u dv is uv. What is u? X. Okay. What is v? Sine x. See, u times v minus integration v du. V is sine, and then du is dx. Okay, and from there to here, the parenthesis, that's integration by parts. Okay, the second term. Now I think you know what is the derivative of sine is negative cosine, right? Okay, so now we have everything. The last I just complete wrote down is here. So 2 times that is plus 2x sine x. So this ended in negative cosine, negative goes to positive. Okay, so plus, because this is 2 times, so distribute the 2 to there, so it's there 2 times cosine x. Don't miss the last, plus c. Okay, thank you. That's all.